I want you to be able to know that this multiplies to this, right? I don't want you to have to go through FOIL every time. So these are important patterns to have memorized. Let's practice. So if this is a or x plus y quantity squared, 3x squared, so make sure you're going to square the 3x, and then you're going to have plus 2 times 3x times 4, and then plus the last term squared, so 16. And you could go much quicker than this, right? So 9x squared plus 12x plus 16. Same thing here. I'm going to use this pattern. I'm going to get x squared, and then this term times 2 gives me the middle term, the x's cancel, sorry, and then I'm going to have a minus a 4, and then I'm going to have plus 4 over x squared. So this is also things you need to memorize. So you need to know how to factor a difference of cubes and addition of cubes. So if it's x cubed minus a cubed, x minus a is the first term, and then we change it to a plus in the middle. No 2 in here, right? There's not a 2 in here like there is up here. So be careful. That's an easy mistake to make. So if it's an x plus an a, x cubed plus a cubed, it's plus here and then it's minus here. So let's go practice. So if I'm going to factor x cubed minus 8, I'd have an x minus a 2, and then x squared plus 2x plus a 4. And let's do this one here. So if I have 27 plus y cubed, you could change it to y cubed plus 27 if you prefer, but that just still doesn't matter. You still get a 3 plus a y, and then I would have a 3 squared, which is a 9, plus, minus, I'm thinking it, but I didn't write it, minus 3y, and then plus a y squared. So this is going to be important and useful as we move forward to simplifying. So let's factor this numerator. I'd have x minus 3, x squared, and then it would be a plus a 3x plus a 9, all over, and you recognize this difference of squares, x minus 3, x plus 3. So you can see these cancel, and then this would be the answer. When I factor a cubic, the addition of cubes or subtraction of cubes, these two terms here never factor anymore. So you can just leave them, not worrying about trying to see if they factor more. All right, let's look at this numerator. So you know 4 cubed is 64. So I'd have 4 plus x, and then 16 minus 4x plus an x squared all over. Oh, wait a second. This does not factor, does it? It's not addition of squares, it's difference of squares. So that's the answer. Just want to make sure you're keeping aware of what you have. So these are basic equations of areas and volumes of things you'll need to know. Just put them down here for your reference. Circles, cubes, boxes, and these are really, really bad math. So it's very bad math to say the square cancels through like that. So you cannot do that. If I see bad math on your paper, I'm going to put big red marks all over the place. You cannot separate a radical around the square root, around the addition sign. So this is not true. And you can't separate fractions around the addition or subtraction in the denominator. You can't just throw away the absolute value bars around the x plus 4 because you don't know the value of x. You cannot move the negative sign inside like that. And it's wrong to say negative a squared is a squared. You would have to, if you wanted to say squared, you would have to put parentheses on there to say it turned out to be the positive 4. So odds and even functions, it's going to come up sometimes. This one is not so much. If a function is odd, then it looks like y equal x cubed. So it looks something like that. And if it's even, it's going to look like y equal x squared. Okay, so if it's even, it's a mirror image across the y-axis. And if it's odd, we say it's a mirror image symmetric about the origin. You flip it over here, and then you flip it down. So the way we check it algebraically if it's odd or even is we substitute negative x in both cases. So if I substitute a negative x in, I'd get negative x to the fourth plus a 2. So you know the negative to the fourth, that gives me x to the fourth plus 2. Hey, that's f of x. So that turns out to be even because the f of negative x is the f of x. And if you thought about it, that's the x to the fourth graph plus 2. So it is an even looking graph. So what happens when I plug the negative in here? I'd get a 2 times a negative x all cubed. So this gives me 2, and I'd get a negative x cubed. So that's a negative 2x cubed. So that is the opposite of the function. So because the function with the negative x plugged in is the negative f of x, that means it's odd. So most functions are neither even nor odd, and then let's look at what that case would be. So if I substitute negative x in, I would get, so then this gives me a negative x, so I'd have a negative x cubed plus an x squared, so that's x cubed plus x squared. Well, this is neither the function nor the opposite of it, so it's neither. So here I give you the graphs of the trig functions that you're going to need to know. They'll be on a future memory quiz to come. So that make sure when I give you a memory quiz on these graphs that you label every single little thing, all the asymptotes, the x-intercepts. Anyway, so it's important to know these graphs.